Chapter 6, problem number 42. A skier starts from rest at the top of a hill. The skier coasts down the hill and up a second hill as the drawing illustrates. The crest of the second hill is circular with a radius of r equals 36 meters. Neglect friction and air resistance. What must be the height h of the hill, the first hill, so that the skier just loses contact with the snow at the crest of the second hill? So the height of the first hill is the unknown. Okay? So h is equal to the unknown. Let's call this A. V at A is 0, so the skier starts from rest. Here, VB okay, we don't know yet, but we do know the radius of this hill. Okay, the radius is equal to 36 meters, I believe. We also know that the normal force here is 0. So we could find VB here because since the skier is traveling on a circular path at the crest, there has to be a center directed net force, and that would be his weight. So we can set that equal to his mass times his acceleration, which is also center directed, which is equal to v squared over r, where I put a b there because that's the speed at the top of the crest. His weight from Newton's second law, again, is equal to mg, right? This is Newton's second law too. This is the net force equals ma. This is the acceleration, mass, net force. Okay, his weight is equal to mg. Notice that mass appears on both sides, so the speed of v is equal to the square root of rg. So since we're trying to find h, let's go back and let's call this the zero potential energy level. Actually, don't call that the zero potential energy level. I think we can call this the zero potential energy level. Then we don't have to tag on this distance of 36 meters. So I think it will be a little bit easier calling this the zero potential energy level. So now the energy at A is simply potential energy, and the energy at B is all kinetic energy. So it's just 1/2 mvb squared. Mass appears on both sides. Solving for h, we get vb squared all over 2g, and vb squared is just rg. Look at that. G's cancel, so h is just r over 2. Wow. So just take half the radius.